National Electrical Code Article 250.118b states that conductors connecting to terminals or lugs shall not be spliced or tapped within the terminal or lug. This effectively prohibits using a single piece of THHN wire to jump the line and load connections in a meter socket. The reason for this prohibition is to ensure a secure and reliable electrical connection. A continuous, unspliced conductor provides a more robust and less fault-prone path for current flow. Splices and taps, especially when improperly executed, introduce points of potential failure such as loose connections, increased resistance, and the risk of arcing or overheating. Firstly, consider the mechanical stress placed on conductors within a meter socket. The insertion and removal of meters, as well as vibrations from the electrical service, can subject connections to considerable force. A single, unbroken conductor is better equipped to withstand these stresses than a spliced or tapped connection. Secondly, temperature fluctuations can also affect the integrity of connections. As conductors heat up and cool down due to changes in current flow, they expand and contract. This thermal cycling can loosen connections over time, particularly those that are not properly taut or secured. An unspliced conductor minimizes the number of potential points where loosening can occur. Thirdly, the NEC emphasizes the importance of minimizing impedance in grounding and bonding pathways. High impedance can impede the flow of fault current, increasing the risk of electrical shock and fire. Splices and taps, if not properly made, can introduce additional resistance into the circuit, thereby increasing impedance. A continuous conductor offers the lowest possible impedance path. Fourthly, proper torquing of connections is crucial for ensuring reliable electrical performance. When a conductor is spliced or tapped within a terminal or lug, it becomes more difficult to achieve the correct torque on each individual connection. This is because the presence of multiple conductors can interfere with the torquing process. Fifthly, the use of a single continuous conductor simplifies inspection and maintenance. It is much easier to visually inspect a single conductor for signs of damage or deterioration than it is to inspect a spliced or tapped connection. Similarly, troubleshooting becomes more straightforward when there are fewer potential points of failure. Sixthly, improper splices or taps can create localized hotspots. These hotspots occur when the connection is not making good electrical contact, resulting in increased resistance and heat generation. Over time, these hotspots can lead to insulation breakdown, arcing, and even fire. Seventhly, the NEC aims to ensure that all electrical connections are made in a workmanlike manner. A splice or tap within a terminal or lug is generally considered to be a substandard practice that does not meet the requirements of good workmanship. Eighthly, the integrity of the grounding and bonding system is paramount for electrical safety. The grounding system provides a low impedance path for fault current to return to the source, tripping the circuit breaker and energizing the circuit. A compromised connection in the grounding pathway can impair the effectiveness of the entire system. Ninthly, consider the potential for corrosion. In certain environments, such as those that are damp or corrosive, electrical connections are susceptible to corrosion. Corrosion can increase resistance, weaken connections, and ultimately lead to failure. A continuous conductor minimizes the number of points where corrosion can occur. Tenthly, the NEC is designed to prevent electrical hazards and protect people and property from harm. The prohibition against splicing or tapping conductors within terminals or lugs is a fundamental safety requirement that helps to minimize the risk of electrical accidents. The correct method for connecting conductors to terminals or lugs involves using appropriately sized conductors that are long enough to reach the terminals without splicing or tapping. The conductors should be properly stripped, cleaned, and inserted into the terminals. The terminals should then be tightened to the manufacturer's specified torque value. In cases where a conductor needs to be extended, a listed splicing connector should be used. The splicing connector should be installed in a junction box or enclosure that provides adequate protection from the environment. The junction box or enclosure should be properly grounded and bonded. The use of wire nuts or other similar devices within a meter socket is generally prohibited, as these devices are not designed for use in such an environment. Wire nuts are typically used for splicing conductors in dry, protected locations. Meter sockets are exposed to the elements and are subject to vibration and other stresses. Listed splicing connectors are designed to withstand these conditions and provide a more reliable connection. The NEC provides detailed requirements for the installation of electrical equipment, including meter sockets. These requirements are intended to ensure that the installation is safe, reliable, and code compliant. Electrical contractors and installers should be familiar with the NEC and other applicable codes and standards. They should also be trained in proper wiring techniques and safety procedures. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. More importantly, it can create a dangerous situation that puts people and property at risk. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and best practices. The NEC is adopted by most states and local jurisdictions in the United States. The NEC is not a law, but it is often incorporated into law by reference. This means that compliance with the NEC is legally required in many areas. Electrical inspectors are responsible for enforcing the NEC. They conduct inspections of electrical installations to ensure that they comply with the code. Electrical inspectors have the authority to issue citations and require corrections if violations are found. The NEC is a valuable resource for anyone involved in the electrical industry. It provides clear and concise guidance on how to install electrical equipment safely and reliably. It is important to consult the NEC whenever performing electrical work. The NEC is available for purchase from the National Fire Protection Association (NFPA). It is also available online through various subscription services. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include state and local codes, as well as industry standards such as those published by Underwriters Laboratories UL. It is important to be aware of all applicable codes and standards when performing electrical work. The NEC is a living document that is constantly evolving. Changes are made to the code every 3 years to reflect new technologies, best practices, and lessons learned from past incidents. It is important to stay up to date on the latest changes to the NEC. This can be done by attending training courses, reading industry publications, and participating in professional organizations. The NEC is not intended to be a substitute for sound engineering judgment. It is a set of minimum requirements that should be supplemented by good design practices and experience. Electrical engineers and designers should use their knowledge and expertise to create electrical systems that are safe, reliable, and efficient. The NEC is a valuable tool for ensuring electrical safety. By following the requirements of the code, electrical professionals can help to protect people and property from the hazards of electricity. The NEC is a complex and comprehensive document. It is important to take the time to understand the code and how it applies to your work. The NEC is a constantly evolving document. It is important to stay up to date on the latest changes to the code. The NEC is a valuable resource for anyone involved in the electrical industry. It provides clear and concise guidance on how to install electrical equipment safely and reliably.